All right, so today's lesson is taking a look at isolating a variable to solve for a linear function. In previous lessons, we've taken a look at what happens or how do we work backwards to solve when we only have one step to do. In this lesson, we're going to be taking a look at when we have multiple steps to do and how do we go through our steps in order and to solve for those steps. So first of all, a little bit of just introduction again. A linear function is an equation which can be used to solve for a variable. Okay. So a linear function is something that can be used to solve for a variable depending on the input value. Okay. Now, in order to solve for an isolated variable, the order of operations can be used. Okay. So again, if we're solving for the isolated variable, we just plug a number into, well, I guess it usually be x, plug a number in for x, solve using order of operations, and we're going to get y. Now, if the missing variable is surrounded by other operations, okay, therefore we're trying to find x, then it needs to be isolated in order to solve for it. So again, if we are given our x value, we can plug it into the equation and solve. It's just a regular operation, and we're finding what the answer is. If we're given our y, or our output, and we want to try to find that input, then we got to work our way backwards, and we got to isolate that variable in order to solve for it. So when a variable is not isolated, the opposite operations need to be applied to the equation to solve for the variable. There we go. So we need to apply our opposite operations. Therefore, and we're going to just go through again a little bit of review as to what our operations are. So the first one, adding and subtracting, are opposite operations of each other. Okay. Terms, and now normally we just deal with numbers at this point, but we're going to take a look at another time at how a term can actually be applied here. Subtracting. So terms and a number is just a term can be removed from one side and placed on the other side through adding and subtracting. Okay, we've done that in the past. We're going to do the opposite. So just taking a look at a couple of examples here, we'll go through a couple of these examples right away. We have x minus 3. To get rid of the 3, and just got to increase my transparency a little bit. There you go. We're going to add 3. And we're going to add 3 to both sides. And when we do that, we isolate our x on this first side here, and on the other side we do 6 plus 3 and we get 9. If we are subtracting, okay, x, and if we're adding here, so x plus 2, we need to subtract 2 from both sides. Again, the opposite operation, and then that will isolate our x value, and we get that x is equal to 15. Again, to isolate by adding and subtracting, we subtract an entire term. In this case, usually it's just a number or a constant. So we subtract an entire term from there. Now, multiplying and dividing, they are also opposite operations of each other. And again, to remove either operation, the other one needs to be applied. Okay, so if we have multiplying happening, we need to divide to get rid of it. If we have dividing happening, we need to multiply to get rid of it. A negative operation, okay, so if we have like a -2 or a -3 in front of our variable, can only be removed by the negative as well. So if we have a negative in front of a variable, we need to remove it by dividing by a negative. Or if we're dividing by a negative, we need to multiply by a negative to remove it. So let's take a look at, again, a couple of examples. This first one here, let's try to get a nice color here. You'll notice how we are multiplying by -3. So in this case here, we need to divide by -3. And we need to do this term as well. There's only the two terms. We do both terms. This is going to cancel out as it equals to 1. And because it equals to 1, it can cancel out. If it equals to 0, remember it becomes 0. We actually want to keep our x there. So this becomes 1. And we're going to get x is equal to, and now 24 divided by 3 is 8. One of them is a negative, so that means that the answer is going to be a negative. Okay, so one out of two is a negative, so the answer will be a negative. Therefore, the answer will be -8. This next one here, and we'll jump into this next one, we're dividing by -6. The opposite of dividing by -6 is to multiply both sides by -6. Okay, we multiply both sides by -6. That should be a multiplying sign. It's not x minus 6. It's multiplying by -6. Again, it's always a little tough to see with some of this drawing that I do here. And when we do this, this is going to cancel out. So we're going to be left with x all by itself. On the other side, we have -30 multiplied by -6. Two negatives give us a positive, and 6 times 30 is 180. So x is going to be 180. And that's how we would solve for solve when there's multiplying and dividing. We can get rid of it that way. Squares and square roots are opposite operations of each other as well. Okay. When a square root is taken to remove the square, we have to remember that there will be two different answers. And this can become tricky a little later on, but there could become two different answers. And there will be the positive value and the matching positive value and the matching negative value. Now, normally it's just as simple as positive and negatives, and when we take a look at a simple operation as we have down here, okay, it is exactly like that. It's just positive and negative. Once we get into a little bit more complex ones, then so when we're taking we're squaring like a set of brackets or so, then it can be a little bit trickier as to what we are trying to find. All right, take the square root of both answers. Okay, so that will cancel out the squared part. And again, this is for when we are squaring it. And so the square root of x squared is just x, and the square root of 49 is 7, or -7. Okay, and again, because when we take a square root, we're not sure which one we actually used. We could have used either or, and that's why there are two different answers to this question. All right, last example here, we're going to take a look at when we're square rooting a value of x, the opposite value is to square. So we need to square both of them. And when we square the square root, it gets rid of the square root. Again, it cancels out. So the big thing that we're looking at is we're always trying to cancel out, and 4 squared is 16, and so that gives us our final answer. Now I want you to work through question 1. It is a bit of review from previous lesson, but again, it goes through the steps and operations that we use to remove certain values from an equation.